Hey, if you caught episode 14 on battery energy storage systems, you already know how much operational and financial value a battery energy storage system can bring to your facility. Today, we're talking about how to make sure a cyber attack does not take all of that offline, along with everything else your controls system runs. This episode is about cybersecurity for commercial and industrial energy systems and industrial control systems. I am Daniel Burke, and this is Energy Answers brought to you by Tactical Energy Group. So here's the short version. Your operational technology, your SCADA terminals, your HMIs, your building management systems, your energy controls, they were not designed to be connected to the internet, but they're connected to the internet now. And that expands your attack surface in ways your standard IT security program does not cover. The question for your operation is whether you have visibility into what's exposed, a sequence to reduce that exposure, and a governance model that treats this as an ongoing risk to be mitigated and managed, not a project you simply complete and close out. If your facility runs industrial control systems, so manufacturing, cold storage, hospitals, utility operations, then this episode is for you. If your electric bill is 5, 6, or 7 figures and your energy systems are networked, this episode is absolutely for you. We're decoding one of the most underprepared risk categories in commercial and industrial operations, ICS cybersecurity. Not conceptually, operationally, what it means for your budget, your uptime, your people, and your potential liability. So, what's the foundational distinction every operator needs to understand first? IT security prioritizes confidentiality. OT security prioritizes availability and physical safety, and those are not the same hierarchy. Traditional IT security tools cannot simply be applied to OT environments because they have the potential to interfere with critical processes, which can mean lost production or physical harm to operators or the public. That distinction is not a theory. It's the reason your IT team's standard tool set is the wrong starting point. Now, why did ICS environments become vulnerable in the first place? OT networks and industrial control systems that were previously isolated from the internet are now becoming connected. Every sensor, meter, SCADA terminal, and building management system that receives an IP address becomes a potential attack vector. The historic assumption that physical isolation protected your operational systems just no longer holds. There are 5 structural vulnerabilities that shape every downstream decision. First, IT OT convergence expands the attack surface. Connectivity that gives you supply chain visibility also gives attackers more entry points. Second, legacy systems lack encryption and authentication. They were built decades ago and were never designed for connectivity. Third, access controls are often insufficient, especially for third-party vendors and OEM contractors with remote access to your ICS. Fourth, vulnerability management lags. Many industrial environments have no tolerance for downtime. Maintenance windows are rare and patches do not get applied on a standard cycle. Fifth, advanced attackers specifically understand these exposures and exploit the hesitancy to upgrade critical systems. Now, these are not a remediation checklist. They are a permanent structural condition you have to manage. Here are 2 specific asset classes that get underestimated: HMIs and building management systems. Clarati's Team 82 analyzed over 125,000 OT assets, including HMIs, and found that nearly 13% of those HMIs are insecurely connected to the internet, and 36% contain at least one vulnerability that has already been publicly exploited. Building management systems, which control HVAC, elevators, coolant systems, and life safety functions in hospitals, data centers, and manufacturing facilities, well, they rarely get treated with the same security rigor as SCADA, and that is a huge mistake. On the threat vector side, the important concept is pre-positioning. Sandworm has developed custom tools for targeting ICS. Volt Typhoon has embedded offensive capabilities in U.S. critical infrastructure, likely for activation during a military conflict. A quiet network is not a safe network. The absence of an active attack does not confirm the absence of an adversary already inside. So, what's the right implementation sequence on a constrained budget? Clarati identifies asset inventory as the foundational step. You cannot protect what you cannot see. Building from that, a defensible implementation sequence in most ICS environments runs through exposure management next, not chasing every CVE, but prioritized by actual exploitability, insecure connection, poor access controls, and operational consequences. Then, network segmentation to limit lateral movement. Then, purpose built ICS threat detection because IT centric monitoring tools were not designed to interpret industrial protocols, and applying them without OT specific tuning tends to create blind spots. Then, zero trust for remote access. Never trust, always verify, especially for vendor sessions. Two frameworks worth knowing by name for governance: the risk management process developed by DOE in collaboration with NIST and the North American Electric Reliability Corporation, which grounds cybersecurity risk inside an organization's broader enterprise risk management program, and CRISP, CRISP, the Cybersecurity Risk Information Sharing Program, a public private partnership co-funded by the DOE and industry and managed by the Electricity Information Sharing and Analysis Center, which facilitates bidirectional sharing of classified and unclassified threat information. Current CRISP participants provide power to over 75% of continental U.S. electricity subsector customers. Those are the frameworks your DOE aligned peers are actually working from. Here's where I land on this. Cybersecurity risk cannot be eliminated. The DOE frames it the same way they frame every other enterprise risk. You manage it through informed decision making, you do not solve it and move on. Annual audits are not sufficient. The threat environment, your connected asset base, and newly disclosed ICS vulnerabilities all change continuously. Security posture is a living, monitored condition. The budget framing that matters most. Clarati describes compensating controls as a bridge until patching is possible. In my experience with commercial and industrial operators, that bridge is rarely temporary. For legacy ICS assets that cannot be safely patched, compensating controls often become a permanent line item. Budget accordingly. Look, I don't run your facility. That's your job. My job is to bring you definitive answers to the most pressing energy questions facing commercial and industrial operators. So, the bottom line on cybersecurity for commercial and industrial energy systems and ICS: your OT environment requires a security discipline that is fundamentally different from IT security, built around availability and physical safety first, executed in a defined sequence, starting with asset inventory and exposure management, and governed as an ongoing risk, not a capital project with an end date. So here are a few questions worth taking to your team this week. Can you produce a complete inventory of every connected OT asset in your facility, including devices installed by vendors and contractors? Of your HMIs and building management systems, do you know which ones have internet facing exposure and which contain unpatched, publicly known vulnerabilities? When a vendor or OEM contractor accesses your control system remotely, what authentication, session monitoring, and termination controls are in place? Are your security tools capable of interpreting ICS specific protocols, or are you running a generic monitoring setup that will produce blind spots in your OT environment? Look, if today's episode got you thinking about an energy operational risk project you have in the works, I want to help. Me and the team at Tactical Energy Group created the Energy Decision Blueprint for Indiana based commercial and industrial operators spending five figures or more on electricity each month. We get on a call, understand your situation, pull your data, crunch it, and give you our full opinion, including what you may not have considered and where the real risks may be. You get the write up and no obligation to anything else whatsoever. So if you're an Indiana based operation spending 5 figures or more every month on electricity, this process is free to you. Click the link in the description below or go to tacticalenergygroup.com and look for Energy Decision Blueprint. Thank you for listening to Energy Answers, brought to you by Tactical Energy Group. If this helped, send it to another operator you know who's dealing with the same headache, and visit tacticalenergygroup.com to get more practical tools for your facilities.